Okay, we'll continue now. Next. Ready?
Go!
Yes.
Sean, get off your phone. Then you'll be ready. Thank you. Now, what we're looking at next is what's called integration. And all integration is what you might call the antiderivative. So let me explain what I mean by that. For example, if I have y equals x squared and I find the derivative, then I'll get dy dx equals 2x. Now, let's imagine I start here and I want to go backwards. I say dy dx equals 2x, then y equals x squared going backwards. That's called the antiderivative, or in other words, integration is another word for it. So, really, it's literally the reverse process, except there's a small problem. So, if I have y equals x squared, I get 2x. If I have y equals x squared plus 1, what's the derivative here?
2x.
2x, still 2x. If I have plus 10, there's still 2x. So a slight problem when I anti-differentiate is I don't actually know what the number at the back is, and so I have to call it c. So I would say the antiderivative of 2x is x squared plus a c. I don't know what the c is. And this is always the problem. You never know what the c is. So, what we need now is the set of rules for how to reverse the process. Before I show you the rules, let me show you the notation.
Sure.
So, if I want the antiderivative of something, I write it in between, let me actually put some colour in here. I write it in between these two symbols. So what this means is find the antiderivative of x. And the purpose of this is just to tell me that what's inside is an x term. So, you know, you could actually have something like this, I don't know, GT dt. It's only to inform me the inside is a t. Yeah.
What if different?
What if different is something we will do in semester 2. So not to worry about just yet. If it is different, it's a problem. We're not allowed to continue. Okay, so now on to the list of rules for integrating, for anti-differentiating. So I'm going to make a table now. Can I scroll down?
Yeah.
Yep. Okay, so here is f, and then here is the antiderivative. Okay, so the first one is xn. Antiderivative of this would be increase the power by 1, divide by the new power, plus c. These rules, if you compare them to the rules I gave you last week, you notice that they're exactly opposite. So last time it was bring down the power and take 1 from the power. This time it's add 1 to the power and put it under. They're all opposite. So for example, sine x becomes minus cos x, and cos x becomes minus sin x. EAX becomes 1 over A EAX, or in other words, EX becomes EX, and of course I'm forgetting plus C in all of these. Okay, 6. 1 over X, that becomes log X, and that makes sense because last week I told you the derivative of log X is 1 over X, so the antiderivative of 1 over X is log X. Yeah. What other ones do we have? I don't think we quite have tan yet. I don't think so. Did I give you any questions with tan in it? No. I see sines, I see cosines, but I don't see tan. So that's fine. No. Okay. Let's have a look at some examples now that we have this table. One more. 1 over AX plus B, yeah. That will be 1 over A log AX plus B plus C. Got that? Yeah, have that, yeah. I'll scroll down. So, let's have a look at our first example. Let's say I want to integrate 1 over root x. I want to integrate this. So what should I do first? Change this to integrate in x power minus a half, yeah, dx. Now the rule says you add 1 to the power. So if I add 1 to this power, I'll get what? 1 over 2. And I divide by the new power. So in other words, I can simplify this into 2 root x plus c. Funny man, Jerry. Funny man. Are you being serious or are you joking? Oh, why not? It looks nicer. Ugly. Beautiful. Yeah? Yeah? Ugly, beautiful? No? You don't agree? Okay. Right, I'll give you one to try now. Write this one down, we'll give you one to try. Can I scroll down now? Yeah. Okay, try this one now. Let's say root x. No, how hard do I want to make this? Make it a little hard. X plus root x plus 1 over root x plus 1 over x dx. Okay, integrate that. Okay. Got answers there? So first I should change this into x plus x a half plus x to the minus a half plus 1 over x. So this one becomes x squared over 2, yeah? This one becomes x, what's up here? 3 over 2 over 3 over 2. This one becomes x half over a half, and this one becomes log x. So this is a half x squared plus 2/3 root x cubed plus 2 root x plus log x plus c. This would be a normal, typical section A question. You know, section A, integrate this. They usually keep it to 3 parts though. Not that it really matters much. Got that? Yeah? Okay, I'll give you one more, but we'll make this one a real hard one now. Oh, well, actually, what I haven't done yet before we do a hard one. What do I get if I integrate a number? 2x plus c. And the reason is, if you integrate a number, that's just like integrating 2x0, which is 2x 1 over 1, which is 2x. So in other words, if you integrate a constant, you just get the constant times x plus c. Yeah? Continue? Yeah? Okay. So let's see what happens. I'll give you 2 more examples. Integrate this. 1 over two minus 1 dx. Yeah. Yeah, that's right. Answer is plus c. Because this is just 1, which is x plus c. Okay, that's just being weird. Right, now on to a real one. Okay. No. I'll do this. I'll make it a good one. On the top, we'll have 3x plus 4, and on the bottom, we'll have 9x squared minus 16. Now, first problem, you don't have any rule for this. So you're going to need to simplify it before you can start. Try this one, see what you can find. Any answers? Victoria, you have an answer? What you got?
Not sure.
Go for it.
No.
No, don't be shy.
No.
Go for it.
No.
What's the first part of it?
The process?
No, just give me the first part of your answer, then I'll know straight away if you got it. Is that the very beginning of it? Yeah. You see, you have it sounds like you have it half right, but I think you forgot it, lost a tree somewhere. Monica, you have an answer? Go for it. Go for it. No? Well, my genius Jerry, you have an answer?
Yes.
What is it?
One
Yeah?
over 1/3.
Yeah, go on.
1/3
Wait, 1/3 multiply log.
log.
Yeah? Yeah, go on. It started so well. Don't quite think it's this, Jerry. Anyone else? You have an answer? What you got? Go for it. What did you get? Tell me.
So we have x over 3 minus x over 4 plus 2.
I don't think that's quite it. Let's have, yes? You think you have it?
1/3
Yeah.
times log 3x minus 4
That is it. Good job. So, sorry, Jerry. We have a new genius. Sorry. Yes, let's have a look at this. So, lots of you had trouble with this, so please watch carefully. Watch. Dude, it's up the front. Victoria's on me. Watch carefully. Now, on the bottom, we can change this if we want into 9x squared plus 0x minus 16. And then that will be 3x plus 4. And if we factorize the bottom, we get 3x plus 4 and 3x minus 4. Because what we're trying to do, we need to get 16 on the back. We need to get 9 on the front. And we need to get a 0 in the middle, which we can if we have them this way around. But of course, what happens here? That cancels with that. So we're left with needing to integrate 1/3x minus 4 dx. And I gave you the rule for that. That's the rule for 1/ax plus b. So this becomes 1/3 log 3x minus 4 plus c. Yeah. Hey, that would. Yeah. You're in the bathroom, wasn't it? Let me just see. Okay. So let me give you some questions to do, but you can take a break after I give them to you. I think. I want you to do, listen, I want you to do, somebody is looking for trouble, listen to me. I want you to do 1z and in number 2 I want you to do t to z. So t, u, v, w, x, y, z. You understand? Number 1, z. Number 2, t to z. T, u, v, w, x, y, z. Yeah?
English.
Take a break. Take a break.